Hello friends, we have been discussing about some interesting facts and properties related to circles. Some properties were proved mathematically and so we named them theorems. So theorems are mathematical statements with proofs. The theorems that we proved in our earlier video were: in a circle, equal chords subtend equal angles at the center of the circle, and if the chords subtend equal angles at the center of the circle, the chords are of equal length. In this session, let's explore some more theorems. Let's consider a circle with center O and AB be a chord in it. Now let's do a small construction. That is, let's draw a perpendicular from the center of the circle onto the chord AB. Let's say the perpendicular meets the chord at point C. Now, if you observe this carefully, we can see that the perpendicular seems to bisect the chord AB, since the length of AC seems equal to the length of CB. Now, let's consider two more such situations. That is, a perpendicular from the center of the circle onto a chord. Even in these two situations, it seems like the perpendicular is bisecting the chord. Now let's see if this statement is actually true. And how do we do it? Yes, by proving it. If you are able to prove this statement, then this will be known as theorem, as theorems are statements with proofs. So what we are trying to prove is that the perpendicular from the center of a circle to the chord bisects the chord. Now, if you remember, in proving our last two theorems, we made use of congruent triangles concept. So even in this theorem, watch out for them. Now, here is a circle with center O and AB is a coordinate. Let's draw a perpendicular from the center of the circle. And let's say it meets the chord AB at point C. Now what we have to prove is the point C bisects the line segment AB. That is, we have to prove that the length of line segment AC is equal to the length of the line segment CB. So how will we proceed? We said that we will have to use congruent triangles concept. But if you observe carefully, we cannot find any triangles in this circle. Wait a minute. If we join OA and OB, we get two right angle triangles in this circle, and they are OAC and OCB. Now, if we prove that these two triangles are congruent, then our theorem is proved, since the corresponding sides of the congruent triangles are equal. Now, how do we prove that they are congruent triangles? First, let's observe the equal measures in both these triangles. If you observe carefully, for both these triangles, the side OC is the common side. So, that's our first observation. Also, both these triangles are right angle triangles, right angled at C. So, the angle ACO is equal to the angle BCO. What else can be equal? If you observe OA and OB carefully, are they equal? Yes, of course they are equal, since they are the radii in the circle, and we know that radii are equal in a circle. So, we concluded that OA is equal to OB, which is the radii in the circle, and angle ACO is equal to angle BCO, which are the right angles, and OC is equal to OC, which is the common side for both these triangles. So, the corresponding hypotenuse are equal, the corresponding right angles are equal, and there is one side which is common. So, Are these two triangles congruent now? Yes, these two triangles are congruent by the RHS congruence rule. So, we finally proved that the triangle OAC is congruent to the triangle OBC, which implies that the corresponding sides of both these triangles must be equal. Therefore, the length of AC will be equal to the length of BC. So, we proved that the length of line segment AC is equal to the length of the line segment BC, which implies that OC bisects the line segment AB. So, what we proved here is the perpendicular from the center of a circle bisects the chord. Since we proved it, this is a theorem now. What's our next job as soon as we prove a theorem? Yes, we have to check whether the converse of this theorem is true as well or not. Now, the converse statement of this theorem is, if a line from the center of the circle bisects a chord, then that line has to be perpendicular to the chord. Now, let's check whether the converse of this theorem is true or not. So again, consider a circle with center O and let AB be a coordinate. Now, the line segment from O onto the chord AB meets the chord AB at C. And it is mentioned that this line segment bisects the chord AB. That is, the length of AC is equal to the length of CB. Now, what we have to prove is the line segment OC is perpendicular to the chord AB. That is, we have to prove that either one of the angles ACO or BCO is equal to 90 degrees. Even here, we will use the concept of congruent triangles. If we prove that these two triangles are congruent, then the angle ACO must be equal to the angle BCO. And we know that the sum of both these angles is equal to 180 degrees since both of them form a linear pair. If both of these angles are equal and if their sum is equal to 180 degrees, then each of them must be equal to 90 degrees, and that is what we have to prove this theorem. So let's try to prove whether these two triangles are congruent or not. So here we are trying to prove that the triangles ACO and BCO are congruent. Again, watch out for the equal measures. It is already known that AC is equal to BC. Now, we know that OA is equal to OB since they are the radii in the circle. And again, OC is the common side. So, we can clearly see that all the corresponding sides of both these triangles are equal, which implies that by SSS criterion, both these triangles are congruent. So, we know that if these two triangles are congruent, then their corresponding angles must be equal as well, which implies that angle ACO is equal to the angle BCO. And we also know that the sum of both these angles is equal to 180 degrees since both of them form a linear pair. So, from both these statements, we can conclude that the angle ACO is equal to the angle BCO, which is equal to 90 degrees. So, we proved that the line segment OC is perpendicular to the chord AB. So, we can conclude that if a line passing through the center of the circle bisects a chord, then that line is perpendicular to the chord. So, we even proved the converse statement. I hope you understood the theorem and its converse. Now, let's solve some problems based on these two theorems. So, here is our problem. In this problem, there is a circle with center O and PQ is a coordinate. The length of the chord PQ is given to be 18 centimeters. The line segment OA passes through the center of the circle and intersects the line segment PQ at M, and it is given that OA is perpendicular to PQ. If the length of the line segment MA is 3 centimeters, we have to find the radius of this circle. So let's do it. Here we can clearly see that OA is a line segment passing through the center of the circle and is perpendicular to the chord PQ. So from the theorem, perpendicular from the center of a circle to a chord bisects the chord, we can conclude that the length of PM is equal to the length of MQ. Since the length of PQ is 18 centimeters, the length of PM will be equal to 9 centimeters, which is same as the length of MQ. Now, if we join O and P, we get the right angle triangle OP. And if we consider the radius to be r centimeters, then the length of OP will be equal to r centimeters, since it is the radius in this circle. Also observe that the line segment OA joins the center of the circle to a point on the circumference, which implies that even OA is the radius in this circle. So the length of OA will also be equal to r centimeters. Now, what about the length of OM? If you observe carefully, OM is equal to OA minus MA, and we know that MA is equal to 3 centimeters. So, the length of OM will be equal to r minus 3 centimeters. So, in this right angle triangle OPM, OP is in terms of r and OM is also in terms of r. And the length of PM is equal to 9 centimeters. So the only unknown is r. So to find that, we can use the Pythagoras theorem, since it is a right angle triangle. So from Pythagoras theorem, we can conclude that OP squared is equal to OM squared plus PM squared, which implies that r squared is equal to r minus 3 whole squared plus 9 squared. Now, solving this equation, we will get 6r equal to 90, which implies that r is equal to 15 centimeters. So, the value of r will be equal to 15 centimeters. That's it. We have solved this question. The radius of this circle is 15 centimeters. Now, the most important step in solving this question was making use of this theorem, without which we would not have known the length of PM. So, remember this theorem. So friends, this is how this theorem will help us in solving such difficult problems. So start practicing problems so that you can get a better understanding of this theorem. In our next video, we will meet with a new concept on circles. Before we end this video, let's quickly summarize what we have learned so far. Equal chords subtend equal angles at the center of the circle. If the chords of a circle subtend equal angles at the center of the circle, then those chords are of equal length. If two triangles are congruent, then their corresponding sides and their corresponding angles are equal. Perpendicular from the center of a circle to a chord bisects the chord. If a line segment from the center of a circle bisects the chord, then that line segment is perpendicular to the chord.